All right. Happy Monday. Good to see you all. Last week of January. Crazy. Love it. The last thing that we saw, which I saw a lot of people had done so far, but not everybody, was really like fourth time through with all of these unfactorable quadratics and just trying to figure out how we can find some x-intercepts with them. The only thing that was kind of new for us was working through the ones that had a different a value, right? And so that's what I want to do. I want to look at numbers 2 and 3 from Friday's work. I don't think we have to do 1 again. It's negative b over 2a, plug it in, see what you get. And we've done a lot of those. I definitely want to work through number 2 and number 3, just so you can kind of see what happens there, see how you did. And then I'm done with that. I think we're at a point where I'm feeling pretty good about how much work we've done with them. If it's something that you are still not grasping yet at this point, it's definitely something we will want to talk about separately. Let me turn off the brighter light, though. I'll be right back. I'm going to erase that. We'll do 2 together, and then I will teach you one quick thing. See how that goes. Voila. A pen or 2 and an eraser. So this is just a check to make sure things went okay for you on Friday or Saturday or Sunday or whenever you got a chance to get that in. I did see some people got some stuff done this weekend, which is fine. But I'll leave up the process over here one last time. But then we will move on and we will look at another way to find those x-intercepts no matter what, okay? And that'll be, what, 2.6? Crazy. We're doing really well. So number 2, hopefully you can see that okay. Let me know if you need you can use a different color or something. All right. Number 2 was, let's stick with the black. G of x equals 2x squared plus 8x plus 4. Cool. And so we don't know how to factor these yet. I will get you there for sure. We will definitely make sure that works out okay. Maybe we'll kind of work our way back to that before we wrap things up. But the process to that point would be, okay, 2 numbers that add to b, so that'd be 8, and then multiply to whatever a times c is, which would also be 8, right? Because 2 times 4. The only way to multiply to 8 is 1 and 8 and 2 and 4, and neither of those are going to actually add up to 8. But good mindset to kind of have going into this is whether or not it's factorable, because if it is, trust me, going to be our easiest way for sure. But this one's not. Okay, so I kind of come off on the side. I do my h equals, right? Because I would need to figure out what h is. I know what a is, which is nice, right? A is 2. B is 8 and C is 4. So good to know, right? I'm definitely going to use that 2 in this part of my answer, though. Okay, and that's what I'm going to do. I'm going to do this negative b over 2a and see what I get. So b is 8, so negative b, so negative 8, and then over 2 times a, so over 2 times 2. It's just nice to kind of simplify the bottom by doing 2 times 2 and getting 4 before I actually do any division so that I don't mess up order of operations or anything like that. And then negative 8 divided by 4 is negative 2. Nice. So that number for sure is going to be something I'm going to use when I drop everything into vertex form. I just need to find the k that goes with it. And I want to find that y value of the vertex, because then I can use that to help me figure out where my x-intercepts are. And that's just dropping in your number anywhere you see an x back in the function. Right? So I'm just kind of going back, right? I'm plugging in this number for x right there and seeing what I get. And I'm at the point where I'm just plugging this thing all into the calculator all at once for sure, and seeing what kind of number I get back. And let's see. So we've got 4, 8, negative 8. So what is that? Is that negative 4? Does that work? Let's see, something like that. All right, because 4, 8, and then -8. Yeah, -4. Does that work? You guys get that? So there's my p-value, and that's what I'm going to use. Okay, and we just kind of see what happens. Let's see what we can do with that, and just kind of go from there. So I'm going to plug everything in. Right, so 2x squared plus 8x plus 4 equals 0. Nah, I can't solve that. That one does not work for me. But vertex form will, right? And just for good measure, so you see it once, there's vertex form without any numbers in it, right? With the a, the x minus h squared plus k. Not something you have to have memorized, that form. I will definitely let you use your notes if that's what you choose to do come test time. And I think I mentioned it last time. If you don't use your notes, I will probably throw you a bonus for that. Okay? But I can drop in a, that's 2x minus h. Well, h is negative, so I got to switch the sign. Okay, so x plus 2 squared, and then k, so minus 4. And there's my setup. Good to go. Now, I just need to start solving, okay? And so I'm just gonna start moving things over to the other side by doing the opposite, going reverse order of operations. So I'll take care of the -4 by doing a +4. All right, so that's 2 times x plus 2 squared equals 4. Addition and subtraction done. Okay, multiplication and division next. So I've got this 2 out here that's being multiplied, so I better divide by 2 on both sides, so that'll cancel out. Awesome. So everything left inside the parentheses, still there, the squared up there, still there, and then 4 divided by 2 worked out really nicely. That's just 2. So I don't have to worry about fractions or decimals. Cool. I like that. If it works out that way, great. Sometimes it will, sometimes it won't. And then square root, right? I can't do my subtracting 2 yet until I take care of that. So I'm going to take the square root of the left, and I'll take plus or minus, don't forget that, square root of the right. Square root of 2 is not pretty. Plug that in my calculator, boop, 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 boop. I get 1.37, whatever it is. So I know square root of 2 is the best version of that number. Square root and square root cancel each other out, so I just have the x plus 2 left behind, plus or minus square root of 2. And then minus 2 to get the x by itself. X equals -2 plus or minus the square root. And we're good. And we're done. Questions on that one while I get things erased so I can slide over here? Voila. A lot of 2s, so it's just not intentional. It's just kind of how it all worked out. Awesome. There we go. First one done. Let's do another one. Sliding over so I can leave that up just for, I need to take a picture in case people want to see it. All right. Number 2, really similar kind of thing because A was 2 there, so I know eventually I'll be dividing by 2. But B and C were a little different. So I guess it's number 3 actually. So h of x, 2x squared minus something, right? Minus 6x. Yeah, minus 6x plus 1. And hopefully now it starts to just feel easier and easier and easier. A is 2, B is -6, C is +1. And I mean, I would love to try to factor. And you're going to see that even when we have A values bigger than 1, it can be factorable. And it's, I think, a lot easier if it is. But 2 numbers that add to -6 and multiply to 2 times 1, I don't think so. That is not going to work. And that's okay. Doesn't mean we don't have any x-intercepts. It just means they aren't going to be the kind of x-intercepts we're hoping for, like nice whole numbers or even simpler kind of fractions or decimals. So I come off on the side here and I figure out -b over 2a, and I just let the math take care of itself. So I need to change the sign up top, right? Because -b, so it's already negative to start. So I make it positive. And then on the bottom goes 2 times whatever a is, which is also 2. So I get 6 over 4. And that's 1.5. Perfect, I can use that. 3/2 would be fine as well if you wanted to stick with the fractions, but don't leave it as 6/4 because that's not simplified. But 1.5 is great. We got a decimal that has an end to it, might as well use it. And then I'll just plug it back in to find the k value that goes with it. By taking the 1.5, plugging it there, and plugging it there. So 1.5 and 1.5. I do not have my phone nearby, so I'm just going to jump into my calculator down here. So I can type it in quickly. 2 times 1.5 squared minus 6 times 1.5. What is that, plus 1? Negative 3.5. So k is negative 3.5. Love it. I've got all three numbers that I need, right? I know a, x minus h squared plus k equals 0. A is 2. X minus 1.5, so I don't have to worry about doing the double negatives there, so that's good. And then plus 3.5 equals 0. Now I just get to it, right? Now I know I've got decimals, but I've got a calculator. And it's going to help me with all of the adding and subtracting and multiplying, whatever I need to do. Of course, starting with adding and subtracting, I'm going to slide that 3.5 over by adding it. Keep my equal signs fairly close to lined up. 3.5, bring the 2x minus 1.5 squared with me. And again, I got to divide by 2 here and see what happens. So that's what I'm going to do. I'm going to divide by 2 on the left, divide by 2 on the right. X minus 1.5 squared, still there, but ooh, geez, 3.5. Cut that in half. Jump into my calculator just to be sure. 1.75. 1.75. Okay. Cool. That works for me. I like it. Decimal's got an end, so I know I can use it. The fraction will be fine, right? What is that? That's 7/4. That's fine if you wanted to really use that. But this works. I don't mind the decimal because it's got an end to it. Let's take the square root of both sides. Get rid of that square because I can't add 1.5 yet. All right. Plus or minus square root of 1.75. I have no idea. So I'm jumping down here and I'm typing in the square root of 1.75 and just seeing what I get. Because remember, some decimals actually have some pretty nice square roots. So I just want to be sure. But 1.32287565553. No pattern, no end. There is the best version of that number. So I'm going to leave it just like that. X minus 1.5 equals plus or minus that square root right there. Of course, add the 1.5 over to get x all by itself. 1.5, getting sloppy. 1.5. X equals. Put the nice stuff up front. I did that on the last one too. The plus or minus the square root at the end. And as ugly as that number is, it is perfect. Ta-da! Cool. Just taking pictures. Climbing on desks. Sweet. All right. How'd you do? Did you do all right? Questions, comments, concerns? Anything I can clear up because done. That's it. 2.5 in the books. Unless there's something you need figured out, we're going to move on. So speak now. Otherwise, I'll preview some 2.6. Maybe we'll just do 1, maybe 2. I think you've seen it before. I wanted to show you where it comes from too, but I'll probably show you where it comes from tomorrow. I'll give it to you today, and then I'll show you where it comes from tomorrow. Good? Okay, let's do it. 2.6. Moving on. 2.6. Okay, this is just a backup. This is a strategy that, hey, you know what? Maybe I don't like that whole vertex form thing. Maybe I want to figure out, God, like, I got to memorize the vertex form. I got to memorize negative b over 2a. I got to remember to plug it in. I got to remember to do it right when I plug the numbers into vertex form, and then I have to solve it well. And maybe that's too much. I get that. That's a lot. It's a lot of things to try to remember. And if you want that bonus, right, maybe you say, you know what? Oh, God. Give me one thing to remember, not 5. Give me one nice way to figure out these x-intercepts. I don't care if they're ugly or pretty. I don't care if they're big or small. I want one thing to remember. Because if I have this one thing, I'll just focus on that and I'll make sure I can do it. Okay? And that's what this is. This is a way that will kind of take all of that vertex form part out and say, you know what? I've got one really nice thing that if you can remember this and know how to use it, it's kind of I think an easier option sometimes. At least it's less work when finding these x-intercepts. Okay, so definitely something you've seen before, but maybe something you didn't master then. There's also some things that come up that I want to make sure that I show you here in 2.6 when we're dealing with quadratics, of course. Okay, and so this only works with quadratics. Okay. And it is a formula that allows you to just plug in your A's, your B's, and your C's, and you just simplify it, and there are your answers, okay? That's why it's called the quadratic formula. And it's just A's, B's, and C's, okay? Now, what we need is we need our function to look the way we like. ax squared plus bx plus c. I need a, b, and c for this. So if it's in vertex form, can't do it. But hey, if it's already in vertex form, I might as well just set that equal to 0 and solve it. Right, if it's factored, this is not going to work. But hey, if you factored it for me, you just did all the hard work. Now I just have to split it apart, and I can set them equal to 0 and see what I get. This is for those ones that show up in standard form that maybe you say, you know what, I'm not going to factor. Or I'm not going to go to vertex form. I've got a way that I know works. Now, this is definitely more work than factoring. But you actually might find it to be easier than 2.5 stuff with the vertex form. Okay, so I just wanted you to see both, and then you can kind of pick the ones that you like. Okay, so what's super nice about this is it's x equals from the beginning. And I will show you where this comes from tomorrow. I'll prove the quadratic formula to you using vertex form. It's just a little messy, but it's okay. I want to give it to you first, and then we can just kind of practice with it just like once today, just so you see it. We'll spend most of the week doing some quadratic formula stuff because some things come up that otherwise wouldn't see. And there's like B's and A's and C's kind of all over the place. And so for now, and you might even remember, see if you do. I wonder if you've got it. We just plug numbers in and then go from there. Okay, so here's the formula itself. It's going to be one big fraction. Okay. Now, what you're going to see is I'm actually going to give you a second version of this that's two fractions instead. And I don't care which one you like. Okay, you can pick whichever version you like. There's something about this second one that makes it a lot easier to deal with, I think, than the first one. That's one big fraction. But I'll give it to you both ways, and you can kind of pick whichever one. All right. Here it is. I'm going to switch colors so it stands out. X equals, all right, on top. So I'm going to do both, okay? Negative b. No big surprise there from our negative b over 2a stuff, right? Negative b. Now I got a square root coming, so I better put a plus or minus. On the second one, the plus or minus just goes in the middle between them. Okay, so negative b, plus or minus. The square root of, and I actually like having both of these versions written down. So if you're writing one, might be a good idea to write both so that you can pick your favorite once you get there. Okay, so negative b on top of the fraction, plus or minus. It's still on top of the whole fraction, okay? B squared is the first thing that shows up. Minus 4ac. Again, this did not come out of thin air. I will prove it to you tomorrow once you let it sink in a little bit. Okay, so the top of the fraction, negative b, plus or minus the square root of b squared minus 4ac. Make sure your square root covers everything, all the way to the end of the c. So the top has a lot going on. The bottom, super simple. 2a. That's it. 2a. Now I have to put that on the bottom of both of these fractions. But you're going to see why this one I like nice stuff up front, plus or minus potentially a square root kind of thing at the end. Okay, but either one is fine. Okay, so you've got this one. And then just a slightly separated version of the same thing. Either one's fine. Okay. Again, you'll see why I like this version later this week. Just a little bit. Okay. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I don't know what kind of Algebra I teacher you may have had, but there is a way to try to remember this kind of complicated formula by singing a little song. Okay? You may have heard the tune Pop Goes the Weasel, right? All around the mulberry bush, the monkey chased the weasel. You know what I'm talking about? So you can sing it to this one too. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Oh, thank you. I'll be here all week. Okay, now that's the kind of thing that's going to take just a little bit of practice to remember which letters go where. But have it in front of you. This is something that you can memorize. It's definitely a lot easier to memorize than maybe that vertex form thing. Okay, and I'll just show you how it works. Okay, super easy once you get the hang of it. All right, so I'm going to make one up or do it together, and maybe I'll just get you out of here and we can pick it up tomorrow. Let's see how it goes. Okay, so I'm going to make up a function. Actually, we're going to do two. I'm going to do one with nice numbers, so you can see the square root just disappears, and then one without nice numbers. That's what we'll do. Okay. So not nice numbers first. Here we go. Not nice numbers first. I don't know. I'll keep a as we'll keep a as 1 for now. So let's call it x squared. I don't know. Plus I don't know, like 5x plus 1. I don't know. Something like that. All right, so x squared plus 5x plus 1. Let's say that was our function. And they ask us to find the x-intercepts. So I'd love to factor, but it's not factorable. Two numbers that add to 5 and multiply to 1. The only way to get to 1 is 1 times 1. And that certainly doesn't add up to 5. So I'm kind of stuck. And you see, I didn't tell you how to find them. I just asked you to find them. So could you do vertex form? Absolutely. Negative b over 2a, plug it in, see what you get, go from there. Okay, this is going to get you to the exact same answer, just a slightly different way. Okay, x equals. Okay, well, a being 1, b is 5, and c is 1. And now I need all three of them, right? Because we've got a that shows up twice. B shows up twice, and C also shows up once, finally kind of for the first time with the x-intercepts. Okay? And I just got to plug in the numbers. I don't really have to do a whole lot besides getting everything where they need to be. Okay? Whether you want to do it in one fraction, or, like for me, I'm going to do it in 2. It's just going to be easier, okay, with the plus or minus in between. Either way is going to be fine. Okay, but we're just going to have to simplify some things a little bit different. All right, so negative b goes first. So b is 5, okay, negative 5. Plus or minus, I'll do all the tops first, because that's how we sing the song, x equals negative b plus or minus square root. So plus or minus the square root of, now I drop in all my numbers first, then I'll let the calculator help me with the actual arithmetic. So b squared, okay. Now there was nothing attached to this -5, so I did not care about putting parentheses around it, right, for negative b. But I've got a bunch of stuff happening in here, so you're gonna see that I'm actually gonna make this fraction bar a whole lot longer and my square root probably a whole lot longer, because I'm going to put every number that I'm plugging in parentheses so nothing gets screwed up, okay? B goes in parentheses, so 5, and then on the outside goes a square. Minus 4, I don't need parentheses around that one. That number was given as part of this, right? B squared minus 4, but A in parentheses, and then C right behind it, also in parentheses. All right, so I've got x equals negative b plus or minus square root b squared minus 4 is c. Okay, so -5 for negative b plus or minus 5 squared, because this one's negative, this one's back to regular b. B squared minus 4ac. And then all over 2 times a. Now, if you did just the one fraction, cool, no worries. If you're doing the separate ones, that's cool too. We just have to write it twice. 2 times a, 2 times a. Okay. Now, order of operations the regular way. I'm not solving anything. I don't have to solve for x. It's already x equals. All of my numbers are all on one side. I just have to put them together. And when we actually follow order of operations, we start at the top and we work our way down. So anything inside a grouping symbol has to happen first. Well, for me, I don't have parentheses necessarily. I have like a bunch of stuff inside. The thing that is grouping my numbers together is this square root right here. And the bottom of my fractions have a couple numbers all connected. And so when I take my time to really figure out what I've got going on here, I'm going to simplify the bottom of each fraction, and I'm going to put all my numbers together inside here. And so what I do is I leave the -5 up top, but on the bottom is going to go whatever 2 times 1 is. Okay, cool, that's 2. Okay, plus or minus. Same thing on the bottom here. 2 times 1, okay, cool, that's 2. And that's, of course, it's the same thing. That's why I'm able to split up my fractions, because I'm going to end up with the same denominator anyway. But what I've got up top under that square root, so I'm not actually going to do the square root yet. I'm here taking care of grouping. Radicals, roots, that'll happen next. I'll actually take the square root once I get there. I'm going to do what's underneath. All in one shot, in my calculator or in my head, 5 squared minus 4 times 1 times 1. Exactly as it's written, because if I use parentheses, my calculator won't screw it up. So I don't actually type the square root in yet. Because if I type the square root of 5 squared minus 4 times 1 times 1, and it's not a perfect square, it's going to give me the decimal. But I don't want to use a decimal. I want to use like the square root of whatever it is, but make it nice. And so I'm just going to type in, or do in my mind, 5 squared minus 4 times 1 times 1. Okay? All in one shot, you'd get 21. So that's me typing in 5 squared minus 4 times 1 times 1, just like that. Okay. Ta-da. Done. That is your answer. Now, if you did it the other way with one denominator with the 2a, okay, -5 plus or minus the square root of 21. And you're good. So I'm good either way. The thing you're going to see that I'm going to show you tomorrow is that sometimes this square root right here can be made a little bit simpler. And that'll allow us to potentially divide by 2, right? Because this 21 trapped underneath the square root, I can't actually divide it by 2. It's not going to work out the way we want it to. But there are ways to simplify radicals if your numbers are bigger, or if your numbers work out in a certain way. So I'll show that to you tomorrow. But there you go. That's it. How much easier is that than vertex form, right? Now, so why did you make me do vertex form? Well, it's because this came from that. Right? We couldn't figure out the quadratic formula if we didn't know the vertex form set. So I just wanted to show you kind of how the progression all went. Okay, let's just do one more with some nice numbers, so you can see what happens when the square root actually works out. But the way I'm going to do it so that you can see the formula is I'm going to come over to the other side, but kind of split the difference, hopefully, so you can still see both. I don't know if it's going to work out if the camera will catch it quite the way that I want. I'll move my setup here. I mean, you have the formula, so it shouldn't be a big deal, but I kind of just wanted to center us on both of those. There we go. Talk to me if you have questions. Say something. My goodness, say something. Have you seen the quadratic formula before? Is that old news to you guys? Or is that brand new? Or somewhere in between? Like, I've seen it, but I did not remember it.
Yeah, I think we might have done it in like freshman year. Okay,
that's what I thought. Like, I feel like it's an Algebra 1 thing that comes up, but I know it's been a while, which is why we're going to spend some time working on it. All right, I'm going to make up another one. We're going to call it good for today. You don't have to submit anything for today. Number 2, g of x. Let's pick something that works out where the square root's going to be perfect. I'll stick with a being 1 for now. A could be whatever we want. Let's go like x squared minus 5x. Let's pick numbers that are good. Minus 6. That should do it. So x squared minus 5x minus 6. Okay. So A is 1, B is -5, and C is -6. And you can write them up and down instead of side by side. I'm just leaving some space for us. But that's it, right? That's all I need. I need that and a pretty, not simple formula, but it's all written out all in one spot. That's kind of nice. I just have to plug in my numbers and then let the math kind of happen, where I just kind of pick on little spots at a time, and then we'll see what happens from there. So x equals, again, I'm going to do it where I use the second version where it's split apart. I just like that so much better, and here's why. You're going to see why here in a second. Okay, negative b. So, all right, I got this fraction here, and then plus or minus this fraction over here. You can do it as the one fraction, totally fine. You're just going to see why I like it right now. Okay, negative b goes on top of the first one, so it's already negative, so I got to make the switch. So positive 5. Nice. Plus or minus a big square root. All right, so big, long square root here because I got a bunch of stuff I got to type in, plug in, write down underneath. Every time I use a number in that spot under the square root, got to use parentheses, especially if I'm going to type it in the calculator to get the answer. And so b squared is going to go right there, right? So b squared minus 4a in there and c in there, right? I've got these empty spots. So maybe you do that first, right? 2 times a, 2 times a. You leave yourself some empty spaces. Whatever works for you. You can just kind of work through it step by step. Negative 5 is b. All right, so this is negative b. This is regular b, right? X equals negative b. Cool. Plus or minus square root b squared minus 4ac. 4 times 1 times -6. Okay, and going back to Algebra 1, my guess is your teacher just told it to you and didn't actually show you where it came from. Tomorrow I will show you where it comes from. So maybe you believe it a little bit. All right, and then 2 times a on the bottom. Switch colors here. Let's see if it'll stand out dark enough. There we go. All right, and now I just take care of kind of the 3 sections, or if you're doing the 1 fraction, the 2 sections underneath the square root and bottom of the fraction kind of separately, right? Order of operations starts with those grouping sections. And the 2 things that are grouping numbers together here are all of the numbers under the square root and all of the numbers on the bottom of the fraction. So that's what I'll do. So first fraction is 5 over 2. Okay, cool, whatever that is, right? And then plus or minus. And now I'm going to end up with a square root on the top still, and then the bottom will also be 2. And then I'll just figure out my square root from there. You know, I'm kind of doing the work under the square root, and then I'll take the square root. Right, square root of 21, not good. All right, we'll see what happens here. So I jump in my calculator. I let it do all the work from what's under that square root. I don't actually type the square root yet, because I'm going to leave it for now. But I'm going to type in -5 squared minus 4 times 1 times -6, kind of being really careful with my negatives, because if you miss a negative, all of a sudden you're adding versus subtracting, or vice versa, and your numbers are going to get screwed up. But what you'll see, if you type all of this in, okay, so you get 49. Right, you type all that stuff in under the square root. You get 25, because -5 times itself is 25. And then, because you got a couple negatives, plus 24. 25 plus 24 is 49. Does anybody know what the square root of 49 is?
Isn't it 7?
It is. And so with the last one that we did, when we type in something like square root of 21, you don't get a nice number, we just leave it, right? The square root of 49 is 7, which means I can do better than writing it as a square root of 49. I can actually write it as 7. And what that allows me to do is actually find the answers. Because what's about to happen is we're going to use the fact that most quadratics, right, you got parabolas, are going to hit the x-axis maybe twice. And what I can do is actually find those 2 spots right now by realizing that plus or minus means, hey, first time, plus, see what you get. Second time, minus, and see what you get. So if your square root is perfect, you have a perfect square under there, here's what we're going to do. We are actually going to split our work into 2 new equations. One that uses the plus and one that uses the minus. So here's what I'm going to do. I'm going to do 5 over 2 plus 7 over 2 and see what I get. And then 5 over 2 minus 7 over 2 and see what I get. Okay? And that's kind of the big difference here, is that maybe you don't realize that this thing was factorable from the beginning, and so you just jump into quadratic formula. Or hey, you jump into the vertex form. I know I didn't do it with vertex form because I wanted to get to here before I did. But you can actually get really nice answers no matter what. And if you just do this, right, let the calculator do the work, or do fractions, right? Hey, if I'm adding fractions and they have the same denominator, I leave the denominator the same. I can combine the numerator, and there's an x-intercept. 12 divided by 2 is 6. Same thing, right? Keep the denominator the same. Actually do 5 minus 7 and get your other x-intercept. And if that happens, that means this thing was factorable from the beginning. 2 numbers that add to -5 and multiply to -6, yeah, we can find numbers that work. And it's just the opposite of those. Right? Because we get x minus 6 and x plus 1. Set them both equal to 0. Whoosh, subtract and add, and we're there. Okay, so there's kind of 2 problems here. And this is why I really, really, really like to split this apart, because then I can just keep the first fraction the same, keep the second fraction the same, and I just have to put 1 as a plus and 1 as a minus. And that's all I want to do today, okay? I just wanted to give you a little preview of quadratic formula stuff so that when we get to tomorrow, I will show you where it comes from. We'll practice it a little bit more. We'll mess around with different values, okay? And we'll kind of build on that on Wednesday and then see where that gets us by Thursday. Cool? I know your math teacher probably has never sung to you before, so another first for us. Unless you had me as your math teacher, then I probably sung to you freshman or sophomore year. Awesome. You guys are good to go. I will see you tomorrow on nothing you need to do between now and then. Thanks, guys. See ya.
Thank you, Rosie.
You're welcome.
Thank you.
Stick around if you guys have any
Thank you,
questions or
Rosie.
anything. You're welcome. Thank you.
Bye, Rose.